Last segment we discussed about three most fundamental vectors, that is the unit vector, the position vector and the displacement vector. Now there are some more building blocks of vectors which will be used, and we are going to discuss them now. The next one which comes in that sequence is called the moment of a point about moment of a force about a point. Okay. So, we are going to discuss moment of a force about a point. What does that mean? Let us see. Suppose you have a plane like this. Okay. Now, on that, let us say we have some point P here, and there is a force lying on the same plane F. Okay. Now, we are now trying to find out what is the moment of this force about this point. And from your knowledge of your 12th standard, you know that suppose the distance, the shortest distance from the point to the force is, say, let this 90 degree, let this be d. So, obviously, the moment of the point P about the point P is is equal to F times d. Okay. Now, this is quite and then feeling wise it should tell you that okay, the moment is nothing but the twisting effort. We had been using that word since we discussed the cantilever beams moment, right. So, basic idea is this force, how much it tries to turn about the point P. So, the lever arm times the F. Okay. Now, suppose this is the line of action of the force. Okay. Now, the force could be anywhere on this line of action, still the moment of that force will be the same F times d, because this shortest distance from the point of concern or point of interest is not changing when we are changing this line of action. So, for calculating this moment, this force is a transmissible force. So, this also should be kept in mind. That means, it gives you power to calculate. How? Now, suppose in a given problem, in some problem, a force is given somewhere here, but the shortest distance calculation is easier at some other point on that line of action. Then you should tell yourself that yes, for this calculation the force is transmissible, does not matter at what point the force acts on that line of action, then I can simply move it to that point and it is done. Okay. Now, but up to this point it is fine, there is no issue at all, it is quite well established that okay, this is the moment which will act. But then the problem starts when the things become more and more complex, in the sense that this calculation of this d becomes difficult. Okay. I mean, here to make it look simple, at least I had created a plane, and then on that I put a point P, and then I had put a force F. So everything was very clear, but it is not the necessary condition. We said that about a point of a force, we never said that means we have to have a plane like that every time. But what I am trying to say is this: suppose that in the most general case you will have the point P somewhere in space hovering, and then you will have the force somewhere, okay, in 3D. Then you have to now imagine a plane that contains both of this, because a line and a point, they will constitute a single plane, and then you will have to imagine this plane which contains this, both of them, and then on that plane you have to find out the shortest distance d. But still, this finding this shortest distance is very tedious. It is a long process if you do not use the step which we are going to discuss now. The most general way to figure this out is to consider, so I'll erase this now, okay. Now consider the vector this r from the point P, about which you are actually trying to find out the moment. Okay. Now then you consider the equation r crossed with f. Okay. What does it give you? Now this r, and if you cross it, so let me draw it here. So suppose this, you can shift it here. So this r cross f means this is the angle which you should take. So that means suppose this is alpha. So if you calculate this, what will you get? R times f times sine of this angle alpha. But then if this is alpha, then say this will be let me use this forever. Okay, this angle, this is beta. Now this, because beta is nothing but 180 minus alpha, you can also write it as r times f, sorry I should have put the bars, times sine of beta. Now r times sine of beta is nothing but d. So this is nothing but your f times d. Okay. So that means if you are using this form, okay, now I'll call it the vector form of moment of p. So these are vectors. Here you just gave, it's not a vector actually. In this equation we are just writing the amount of the twisting moment. We are not at all talking about in what direction, but this one is a complete vector equation. So this is what we call our powerful vector, the moment of a force about a point. So then we saw that how finally it calculates only this much, but you do not have to think about anything, and the actual power of this method lies in two things. One is that first thing, you have to think that this force is transmissible, it can be anywhere on that line of action, and then the vector r you can draw from P, that is fixed, but to anywhere on the line of action of F. That means I could have drawn like this, R2. Now R2 crossed with F also will give me the same result, because R2 sine of beta 2 is again D, the same D. So there lies the major power of this method, or this form of the calculation of the moment. Okay, that means wherever the force is acting, doesn't matter, you have to pick a point on the line of action of the force to join that point to this point, so that it will be convenient for you to calculate this position vector of this point on the line of action. Because it is not always easy or the same level of ease with which you can calculate the position vector of any point with respect to P, or the displacement vector from P to any point on line of action of F. It is not the same at every point, and once you see problems, you will notice that at some locations it's very obvious to find the line of this displacement vector. But some other point, if you choose, maybe there the force is actually being applied, but the calculation of the position vector to that point will be really hard. So there you will have to use your concepts of transmissibility, then the displacement vector, and the power of the knowledge that this vector, displacement vector, could be any from P, but to any point on the line of action. So that is what you should do to calculate this. Okay. So this one of our say in that sequence we had unit vector, position vector, displacement vector, and I will name it say fourth point, or in our ammunition this is the fourth armor. The moment of a force about a point. Okay. Yeah. So then in the next segment we will see one more such special vector.